and I'm taking up some of the requested questions, and then we will go to the boards. So let's start off with 2i. Okay, and so we've got 1 over 5 x to the power of 4. All right, let's, folks, remind ourselves of the new vocabulary. So what do you call the 1 that's not new? Numerator. What's underneath? Great. What do you call the 4? That's old stuff. What is it? No, just the 4. Yeah, it's the exponent or the power, right? In terms of the exponent, it's the power part. Okay, what is the 5, or what is the 5 called? The index. Good. What is this sign called? Radical symbol. Good. A radical sign. Cool. And what is the thing that goes inside? The radicand. Don't ask me what that means. I don't know, but it's a word. Okay. So if you're like not great at words like me, you're keeping a list of terms, right? I have a piece of paper. If I were you, I'd have a piece of paper that's like radical symbol, radicand, right? Like that's what I would do, because words do not come naturally to me. Okay. All right. So in this question, we are supposed to we are converting an expression. This is an expression because there's no equal sign, so there's no equation. So we're not solving for anything. We're just changing how it looks. And so we're going from the radical form. This is radical form because it has a radical sign, to rational exponent form. Now, a rational exponent means there is a fraction in the exponent. Okay, that's all it means. Rational exponent, there is a fraction in the exponent. Well, what is the base? The base of the fraction is always the radicand. Okay, and then we have the power in the index. So the power is the numerator, because before, when we just had a random exponent, it was always just an integer. So the 4 stays where it used to be. What we add now is the index, right, which goes in the denominator. And now I have to represent the fact that all of this is in the denominator of the fraction. So how would I do that? Yeah, Ben. Greg. No. Luke. I would use a negative. Sorry. I'm going to give you 2 sympathy points for making a mistake and me just saying no like that. Do you need those? So watch this. So I could have done this, but I didn't want to do that. I wanted to do everything in one step. And so by putting a negative sign in the exponent, the negative tells me, oh yeah, all of this actually resides in the denominator. Got that? And so when you have a rational exponent, the numerator is the power. So to the power of 4. The denominator is the root, right? We also call it the index, but this is the root. So I'm taking the 5th root, the square root, the cubed root. Okay, I don't know how to say 5th root. I just say 5th root. Okay, does that help? All right, let's do question. Let's do question H, but I'm going to have you do it. Okay, so 2H, I wrote it here. Go ahead. Okay, when you're ready, look at this, look at the answer, ask me questions. Even though there is no power of 1, or it doesn't say, we know it's there, right? We good? All right, let's go on to the next question from question 2, which was L. So L has a radicand of 5t cubed. And it's all being taken, the fourth root is taken. So Lila, can you see normally? Can you see fine? Okay. So for this one, it is a bit tricky because there is an exponent, like there is a power, right? Now, which term, variable, coefficient gets the power of 3? Is it both of these or just the 5 or just the t? I knew it. Just the t, right? Not the 5. Good morning. I'm going to do it right now. All right, I'm going to turn the screen off. I'm going to do attendance. So it's just the t that is getting the cubed. How about the fourth root? Both or only one? Both. Okay? So go ahead and try that. Is going to be 5t cubed. But this is a bit tricky because I don't do this, right? I don't add brackets. Is that better? Okay, I don't add brackets because it's only the t that is being cubed. However, both are raised, are taking the fourth, both of them are under the fourth root sign. Now, if I write it this way, I have not fully simplified it. I want to, when you simplify, you want to get rid of as many brackets as possible. So what that means is we multiply each exponent by the 1 over 4, right? Or we just straight away give it a denominator because it's the fourth root that is being taken. We take a denominator of 4. And because the 5 doesn't have a power, well, it does, right? It's the power of 1, which we don't write. So does anyone see a mistake that someone might make here or like a misconception? Luke, yeah.
It might be what I did.
Yeah.
3 over 4 for the whole thing.
Got it. Yes, I think that's a very common mistake. That's why I'm glad we're doing this question. So 5t, and I really appreciate that you own up to making the mistake, right? Because it's like, it's a good mistake to make. And then you're really learning from it. So this is a very common mistake. Anyone else make this mistake? I feel like this is, right? It's a mistake I would have made. All right. Other mistakes. Yeah.
I have a question about why don't we put a negative instead?
Ah, okay. Okay.
Because we did for the other ones, like we put a negative, we did a and then negative 1 over 3.
That's right. Okay, so what I want you to do is I want you to look at those two questions, the purple and the teal one, and then look at this blue one. And what is different?
Yeah, they're not in the
Good. But you answered your question, right? So I really want to take away this embarrassment, Sophie. I think it's a great question. And you know what you get from asking it? Understanding. Okay, folks, I want to tell you, when I was in university, I decided, okay, when I was in OAC, which is grade 13, I learned that if I ask, it's mind blowing. I learned that if I ask questions, I will understand. Like, ooh, crazy. And then I kind of got like selfish about it. I was like, you're going to have to stop the lesson because I don't understand this. So, like, I didn't say it that way, but I would ask questions. As soon as I didn't understand something, I would ask questions. And then, Liam, do you know what happened? In first or second year, I was applying for a scholarship, and I asked the Dean of Mechanical Engineering to write me a reference letter. He was teaching me dynamics. and I asked him to write me a reference letter. Do you know what he wrote in that reference letter, folks? He said that I was the student, because I really asked the most questions. Like, I'm not asking you to be that, but he said that I was the student that helped him understand if he was teaching too fast or if he didn't explain something well, because he knew that I would ask a question. So I was like a thermometer for him, right? I was giving feedback of like, that was not taught well, or you're going too fast. Do you see what I mean? And so he actually wrote that in a reference letter, that like that was something that he really appreciated about me as a student. So I love it when students ask questions, right? Because it helps me know, oh, you're going too fast, or like you're bringing in, or you're saying questions that at least 3 other people have, right? So you're doing people a favor. The other thing that would happen is people would make fun of me for asking questions, like in like a joking way. Um, but then, like this one guy that used to make so much fun of me for asking questions, there was one day that he like was like, "Hey, Ivanka, can you ask this question?" Because he was too embarrassed to ask it, but he like turns out really liked that I asked questions, right? So I love questions, is what I want to say. All right, all that to say, thank you for your excellent questions. All right, okay, so that's another possible mistake. Why don't we put the negative there? Okay, are we good to move on? Okay, let's go to question 3. So we've got 3E that was requested. So now, which form is this expression in? Is it in radical form or rational exponent form? Rational exponent. There is no radical sign. It's not radical, right? So it's not a radical form. Okay, so if this is a rational exponent form, where's the rational exponent? Huh? Where is it, Claire? So what should I write instead of the decimal? 1/2. Right. Oh, 0.5 is just 1/2. So really, what does 1/2 tell me that I'm doing? I'm just taking, that's right, I'm taking the square root. Yes. Do I have to write the index? No, because if you have a radical sign without an index, the default or the assumed index is a 2. So if you want to be fancy, you can write it, but it's sort of like, it's like we never write the exponent of 1 because it's assumed to be there. And what are we asked? So I go back to the question and it says evaluate. So am I done? No. Now I'm done. Okay, evaluate, find the value. Okay, let's do L. That is a nice whopper for you. Okay. Now I want you to write this first in radical form. Like, yes, you could pop this into your calculator, but on the quiz, you're going to get half a mark for knowing how to use your calculator, right? So first, write it in radical form and then evaluate. Okay, maybe I need to write it on the quiz. Convert into radical form, then evaluate. So the brackets tells me that both numerator and denominator get the exponent. Okay, sorry, I'll stop talking. I'll let you do your work. And then, Amelia, we will get to your question. And so if you need, you can take out a calculator for this, but I want you to be able to do this kind of stuff without a calculator, right? So we're really working on our times tables, on our cubed roots, not just squared roots. Right now, let's get comfortable with what are our cubed roots. What's the cubed root of 27? What times what times what? Oh, 3. Yeah, I see it's about 9. Okay. Yeah. What's the cubed root of 8? What times what times what? 2. If you're not sure, be like, well, it's got to be less than 3. Let's try 2. Okay, but what is the cubed root of negative 27? It's not 3. It's negative 3. Because it's not the same thing.
Well, they cancel out in the end.
Okay, but that's different. I would actually take half a mark off if you didn't write it this way first. Okay, because you're showing me that you understand that negative times negative times negative is negative. Lila. Potentially. Yeah. Yes. I as soon as I said that, I'm like, yeah. But just like there might be another question where it's like, if it's like negative 27 cube root over cube root of positive 8, right? Then make sure that you're like, oh, I know that's negative over positive. Yeah. Is that the answer in the question in the back? Yeah. Sophie, go ahead.
Can you go through this one?
Yeah. So in this case, I would say, okay, so cubed root means it's one number multiplied 3 times. Okay. And so in this point, if you don't know how to evaluate this in your head, you pull out your calculator and you find the cube root. So let's take out our calculators. Let's make sure everyone knows how to find your cube roots. And if you do not have a calculator here, bring it tomorrow. You need to have a calculator, right? Because we're talking cube roots. And folks, keep in mind that if you're writing a test and you don't know how to use your calculator, I don't actually help you, right? That is something you need to learn ahead of time. So some people might have this button, but the button I really want you to look for is, it might look like this, where you can use any index, right? Look for that button on your calculator and learn how to use it. So the way you're going to learn how to use it is you're going to punch in 3, and it should equal negative 3. And you might need to change the order. Okay, Eloy, take out your calculator. So you should arrive at an answer of negative 3. Every calculator is different, right? You might need to change the order. Anyone not sure what they're doing? You want me to look at your calculator? Good. Because then if I give you like a 5th root, if I'm like, okay, what's the 5th root of 32? Right? You're like, yeah, no problem, right, Muntaha?
Yeah.
Could you do it? 5th root of 32? Who figured out how to use that special button? You got it, right? Who's got the special button down pat? Only one person, 2 people? Special button. All right. So folks, you bring extra help. Good. If you need more help, you bring it extra. So does that help you? Excellent. Good. All right. Let's move on to 5. So we're going to do 5n. We've got 0.027. I know there's an ugly exponent there, but what do you see? What does 27 let you know? Yeah? Divisible by 3. What's the cube root of 27? Oh, interesting. And look at the rational exponent. The index is 3. So we are taking a cubed root. Okay. Not so scary. 0.25. Yeah, it's a decimal. But what do we know about 25? You can take a square root of it, right? Square root is 5. And what's look. What's the index? 2. We're going to be taking a square root. Okay, ugly decimals. I can take you on. Now, first things first, let's get rid of those negatives, right? So show me with your hands. What do you do with the negatives? Ba-ba! Not a full circle, Liam. Just 180. Like he got way too excited about it. Just a 180. Yeah, thank you, Marley. Yeah. All right. So what Liam was trying to say, I'm going to give him some 5 points for allowing me to pick on him. But you got 5 points. It's worth it. So watch what happened. We didn't, watch this. Okay, I feel like a common mistake might be that people try to flip the rational exponent. Is that possible? Someone might think, oh, I gotta change the exponent, flip it, where literally the exponent doesn't change, the base doesn't change. I'm just getting rid of the negatives by making the numerator the denominator and vice versa. Okay, so now we have no negatives. This is easier to work with. All right. So now I write it, instead of in rational exponent form, I'm going to write it in radical form. And in this case, I'm definitely going to use a calculator because even though I know it's a base 5, I actually don't know. I think it's going to be 0.5, but I'm not sure. So we've got index of 3. And folks, here's the thing. Okay, with the power, watch this, Marley. So you've got 2 options. You can put the power inside here, like the squared, or you can write the power on the outside. I prefer it this way because I like to take the cubed root first, right? Because then it simplifies it, and then I square whatever I get. But you will get the same answer if you go the other way. Yeah.
If you write it without the brackets and you put the square on like the 27, do you have to evaluate it in one step, or can you still take the 2 seconds or so?
Absolutely. Yeah. That's fine. Okay, so we're probably taking out our calculator. I'm going to guess. You're going to tell me if I guessed it correctly. Ooh. Okay, I'm totally guessing there. Yeah? Nice. Thank you, Claire. Pardon?
0.09.
Okay. Yeah, that was the tricky part. My math brain is not that good. And then did they want us to evaluate it further? Evaluate in the real system if possible. So 5n. Oh, okay. Very fair. So then I look at the answer and I'm like, yeah, this is not cool because we don't like to leave a fraction in decimal form. So how do I get rid of the decimals? Well, if I multiply both, don't do this. If I multiply both numerator and denominator by 10, right, that means the decimal moves over 1. I get 5 over 0.9. Well, I still have a decimal. So what do I need to multiply numerator and denominator by? 100. And the other way you could figure it out is you're like, I need to move this decimal 1 and 2 spots. Okay? So times 100 times 100. And that gives me 50 over 9. Yeah. No. Oh, Marley, is the class being really loud?
No.
Okay.
We're good.
Okay. And let's do one. I'm not going to do the other. I'm just looking at the time. I want to do a bit of a lesson still. I know. But I'm glad we're taking time for this. And then, sorry, I meant to go. No, I'll do it later. Let's do one question for question 6. And what do you want, D or J? I feel like D is a good one. 60. It's nice and ugly. With two radical signs. Really, Miss Sly? On a Monday morning? You're horrible. I know. Okay. So step one is going, okay, so what does it say? Communication. Write an equivalent expression using exponents. So all I'm doing, I'm not evaluating necessarily, I'm just changing it into the other form. Now, that 8, I might be able to evaluate, I might not. So first things first is let's rewrite it using rational exponents. So the 8 and the x to the power of 7 stay. Now I'm going to use brackets to show the to show the cubed root. So watch this. The first radical expression is the first radical sign is a cubed root, right? I'll use some colors. And the second radical sign is a squared root. Does this kind of make sense? I used colors just to show which one's which. Okay, so I'm showing both, and it's almost like those radical signs are becoming brackets. Well, it's not almost like, that is what's happening. And the radical sign inside is the inside bracket. Okay, what can I do with the two exponents? Multiply them. Yes, you got it. Yes. Like the exponent laws. I can multiply them. Isn't that fun? What's 1 over 3 times 1 over 2? Yeah, it's so fun. It's 1 over 6. That's really what I wanted, Miss Sly. Great. And now, I'm slowly getting rid of the brackets. I got rid of one bracket by multiplying the two exponents. Now I get rid of the second bracket by writing rational exponents. So what will be 8? Well, it's going to be 8 to the power of 1 over 6. How about x? What will be the rational exponent, the fraction exponent? What do you think? You got it. 7 over 6. Right? 7 times 1 over 6 is just 7 over 6. But if you're not sure how to multiply fractions, you can always, or a fraction and an integer, you can always make the 7 into a fraction, like 7 over 1. And then you multiply the numerators and you multiply the denominators. All right, now is that where they left us? I just want to 6D. No. Okay, so 6D, we went further because we recognize that the 8 is a power of 2, right? So instead of writing 8, I can write 2 to the power of what? Yeah, 2 times 2 times 2 is 8, right? And now I multiply those exponents, so I get 2, 3 over 6. Well, and 3 over 6 is just simplified to be 2 to the power of 1/2. And there are different ways to get to this 2 to the power of 1/2, right? I think I made it a bit of a long way. I'm going to show you the shorter way. So instead, the other way to do it, instead of multiplying these two exponents, we could have first done the inside exponent, right? The other option is to say, actually, I'm going to just do the inside bracket first. So I've got 8 the cubed root of 8, right, which would be 2, and then x to the power of 7 over 3, all to the power of 1/2. Do you see what I did here? Like I basically said, well, that is 8 to the power of 1 over 3, which is cubed root, and that gives you 2, right? So that might have been the better way because that got you to the 2 faster. In these questions, there really are many pathways you can take. Okay, so I'm not going to solve any more of those questions. I'll post these. Okay, I'll post this PDF. I'll post this video. And then I want to go back to the one question, which is the thinking question from the note. So let's look at this thinking question. If the index, right? So this is the index. If the index is even 2, 4, 6, 8, then the radicand must be positive, negative, or both. So if I have a square root, can I have a negative radicand? If you try it on your calculator, you get an error. So it can only be a positive radicand. However, we saw some negative radicands, right? I had the cubed root of negative 27 being negative 3. So when I have an odd index, in that case, I can have a negative radicand. So in that case, the radicand can be both positive and negative. Amelia, does that make sense? Great. We good? All right, I'm going to give you a 2-minute break. Stand up. Who wants to do jumping jacks? Who wants to do push-ups? And who wants to do burpees? Do it. All right.